Today we'll cover chapter 6 and we'll talk about delivery and forwarding and we'll see what that's mean. That's going to be include talking about routers and how so the objective of this class today is to discuss the delivery and if we talk about delivery, we talk about the remember now each host has 7 layers or 5 layers for TCP. Okay. And the network layer is responsible to pass to the next hop, from next hop to next hop. And if you remember, router itself has only 3 layers. It has physical, data link layer, and link layer. So that's why when we talk about delivery, about this layer, the top of that you would have the transport layer and application layer. That's within the host. That's an internal layer, and we will have different function. But to send a packet from a host to host, that's the network layer job to make sure it's delivered, and we'll see that. So there is 2 types of delivery: direct and indirect. We'll see what that means. Then we'll see the forward. From the name, what's mean forward? Just receive something, translate it, find where it has to go, and send it to the next hop. So that's really the router job, to deliver the packet to the next hop. The next hops are based on the destination address. So there's 2 ways: either based on destination address or based on labels. And we mentioned that before last time with the label. So we don't have to remember the whole just label. So first you will explore the path, establish the path, give a label to the path, and after that just send the packet using the same label. And we'll discuss that. So what is the different forwarding techniques? Okay, next time we'll discuss the techniques. Now we'll see what's the difference. Then we'll go over the router. What's the router table? Because remember, each router has a table. That's the only way how router will do the job to transfer the data by looking at the table. Let's find what's the next one. We'll see. So, and if you remember, we went over the cluster and the cluster. So there's different types of IP addresses. And so the exam we cover that very well. The cluster. And we'll see some of the search table, how we search, how we'll find the destination. Then maybe we'll skip that, but we'll see if we have time. We can go over them. PLS technology. We'll see. The last thing we'll look at the actual component inside the router. How does the router look like? We know the router is a smart device and has components. We'll see what. So now let's talk about delivery. What we mean by delivery? Simply, find the path for to send the data. So which route we have to send this packet to the other destination. So the purpose, to make sure to deliver the packet. So who's responsible for this process is network layer. We mentioned. So the network layer supervises the handling the packet by underlying physical network. So network layer, we will make the plan for data link layer and for physical. Now we'll see how. Okay. So we define this handling as delivery of the packet. The delivery of the packet is final destination. So we say direct and indirect. So we'll see what's the difference. And how we do the delivery next? How we do the delivery either by forwarding based on the destination address. So you will have the destination address, and based on that you deliver. Or based on what? Label. So we mentioned that before. And we'll see. What is the direct? How does the direct happen? So the direct, when you deliver the packet to next hop within the same network. So you're not leaving the network. So when you're trying to deliver packet from A to B, that's internal. A and B within the same network. So it will be easy to find the address of the B because it's next to you. You have the router. It's gonna find it for you, and you don't have to go outside. You don't have to look for another. So there is two direct. So from host to host, or from the host to the. So from host to host, or from the router to the host within the network. Because remember, the router itself has two interfaces or more than that. One for the network I'm with it, and the other for the other network I'm connected to. So actually I have it. So the router has an interface. So this interface, it's belongs to this network. So which is mean, you're going to the same network, so you don't have to go outside. So that's the direct. So to find the destination, it's really easy. Why? Network ID is the same. Only you have to find the destination. The last interface. Yes, the last interface or the last bit. So the sender can easily determine the delivery is direct by how you know it's direct. If the source, how you will know the connection now is direct connection.
Yeah, if we send directly to the same network.
How you know that?
Like using the signal network.
Yes, but if the source IP address and the destination IP address has the same network.
Yeah.
So when you compare both equal, that means I'm the same network. I'm not going outside. So for example, if the source is 10.10.10.100, that's source. The destination is 10.10.100.200. So, and let's say, that's, remember, that's let's talk about the class. Let's say, that's plus 8, and that's plus 8, right? So what is the network address here? Just 10.0.0.0, correct? What about that network address here? It's going to be 10.0.0. So this one equal to this one. So what that means? It's 7. So it's easy to identify. You don't have to spend a lot of time to travel. All right. So how you extract the network address, as we said here. So that is if it's a classful. Now if it's a classless, what you will do? If I will give you an IP address 10.20.20.100, I will tell you that's /8. So what is the mask? When you have /8, what's your mask? 255.0.0.0. Because what you will do, you will make the first 8-bit ones and the remaining zeros, right? So when you do a mask between IP address and remember how we find the network address? By AND. We do an AND. When you do AND 100 with 0, it's going to be 0. 20 with 0 is 0. And 20 with 0, 0. Then 255 with 100 with 10, it's going to be 10. So we learned that from last time. So we know that is the network address. So how we can find if it's a classful? If it's class A, B, C, you can tell right away. If it's classless, you have to use the mask. So that's how we use the mask. So if it's a direct connection or direct communication or delivery, you have that destination address. Now it's there. Now what you have to do next?
Just deliver the.
Yes. Are we using IP address to deliver?
Yeah.
You use it. Yes, but usually we translate the IP address to what? Physical address.
Okay.
Correct. Because data link layer, they use the MAC address. So that's the thing. You need an algorithm to find to map the IP address to the physical address or the MAC address. And this protocol called R, we'll discuss in chapter 8. We'll see that what's called address resolution protocol. That's going to help us to find that. So that's the direct. It's really simple. Not much there you have to spend. Now let's talk about indirect. What is the indirect? The indirect simply when you deliver a packet from between router to router. So always when you deliver the packet, just think about that. If I want to deliver from A to B now here. So what is this link here? That's direct, correct? Because still I'm with it in the same network.
Yeah.
So that's direct. Okay, what about this one?
Direct.
Direct. What about this one? Indirect. Right? So if any communication happen in the network has to have at least
One direct.
one indirect connection. Okay? And how many indirect?
It depends.
Zero
No,
or
it
more.
depends. Zero or more, yeah.
Because if you just deliver from the A to B and they are both in the same network, you don't have indirect.
Yes.
So that's why we call it it's either zero or more. But the direct one, at least one. And always the last one, like for example, from hub to hub to hub, the last one always can be direct. So so that's the thing, that the connection or the delivery between router to router always
Yeah,
indirect,
sorry.
right? So this one is direct. This one is direct. I don't know. This should be direct. I don't know why they say it direct. Then the last one will be direct.
Yeah.
Correct. So how will you find out? What's the process to know if it's indirect? So the sender uses the destination IP address and the routing table. Remember we mentioned routing table. We'll cover it now. Okay, to find the IP address of what is the router? Like I'm going from router. Is the router care about what is the final destination?
No.
No,
It
it's
cares
care about the
next
next one. What's the next one?
The
Of
next
course, it's
route.
gonna be based on the destination router. But my goal now to find what is the next hub to send the data to. And the next hub, when you receive it, they will find the next hub until you reach the destination.
Yes.
So that's why sender use the destination IP address and routing table to find the IP address of next router. I don't care about the final destination. I care what is the next router. Then that sender use ARP, the same thing, because that's what you care about. Physical, you need still physical address. So ARP is going to help us to map that. So note the direct delivery, the address mapping between IP address and the final destination and physical address of the final destination. Okay, so note that direct delivery, the address mapping is between IP address of the final destination and physical address of the final destination. In indirect delivery, the address mapping is between. Oh, I'm sorry, that's for the direct. I got confused. So the direct, it's you do mapping between the final destination and the source destination or the final physical address. And then indirect, what you do mapping between what? The IP address of the next router with the physical address of that router. Right? So that's what you. So direct, you care about the final destination address and the final MAC address. In the router itself, you're looking for what is the next router. Right? Now the delivery always involves one direct, as we mentioned. Always there is one direct. However, we have zero or more indirect. No, also the last delivery is always direct. Right? So let's do that. Now, what is the forwarding?
If we have something, we forward.
So yes. So in the network in general, it's not just one router to route. It's really multi-connect of networks. So it's going to be hard for you to know all the network around. So for you, you just forward. I want to send the packet from A to B. What I will do, I will forward it to router one. Router one, what will do router one? Just will forward it to the next hub. Okay. Router one does not care about what is the final destination. I care about what is the next hub for. So that's what they call it forward. I just receive the packet, open it, see what is the destination address, know what is the next hub, and just deliver it. So forwarding means place the packet in the route to the destination. Since the internet today is made of combination of links, networks, forwarding means to deliver the packet to the next hub. So again, what do you do forwarding? Next hub. That's what I care about. I do care about the destination. Next hub, I aware. So even the next hub, maybe it's the destination.
Yeah.
So maybe that's the last route. So it could be the destination or just next route until you reach out to the destination. All protocol was originally designed. So originally, what is that? The IP protocol was connectionless. What means connectionless? We explained that before.
It's fine.
Connectionless, you send the packet, okay? Based on the network path, you just find a path, okay? And that's only for that packet. Next packet maybe will go to different route, okay? That's how you find any available path, more available, fastest, and you send it through that path. What about the connection?
That packet only follows that way. It only uses that router. It doesn't.
Remember, we have 3 steps. We'll have established connection. So what you will do, you will go first is find the path you want to follow. Okay. Then after you establish the path, you're sending the data, and all these packets gonna follow the same path. Okay. And after you finish sending everything, what you have to do? Tear down the connection. So that's the connection oriented. So that's why now most of the protocol is connection oriented for reasons, and there is some type of data use connectionless, because connection oriented costs you money and time, because you have to first you have to visit. That's time. Visit, establish, and reserve. So nobody else can use the same path until you finish. Connectionless, no. You send, and maybe somebody else will take over. So you can send multiple things at the same time. All right. So what is the forwarding based on destination address? So that's, remember we have 2. We say based on the forwarding address, destination, and based on the label. So what's the difference? Forwarding requires a host or router have a routing table, right? So all the computers has a routing table. The router has a routing table. So the routing table, what's going to benefit you? The next hub.
Oh, yes.
Maybe it's a router, maybe it's a destination.
Yeah.
All right. So that's the routing table. That's what benefits routing table. So based on the host address, the table is going to tell you what is the next hub. So and we'll see there's different type of that. So something called next hub method, network specific method, and host specific method, and default method. How that look like? So let's say I'm trying to route a packet from A to B. So remember, A will has a table, R will has a table, this one has a table, R has a table, and this one has a table. Right? So let's see what A has. So the routing table based on route. So if you want to define the whole route, so if you want to go from A to B, can you tell me which way I have to go? I will go to R1 first, then R2, then destination. So what do you have in that A? If you want to go A, and if you want to go to host B, what do you have to do? If you want to go to host B, you have to visit R1, R2, host B. Now, if you want to go from R1 to host B inside the router 1, just you will go through R2, then now if you want to go from R2 to host B, what you want to do? So that's why the direct connection, correct? So that's based on the route. So you list the whole route. Okay. Again, nobody using that wall. Because now you have to really define the whole path. You have to go and find exactly which path. The second way, okay, which is based on next hub. So for you, what you care about, what is my next hub? So for example, I'm trying to send from A to host B. So host B, I will know I have to go through R1. Okay. So now R1 has a destination for what is the next. If you want to go to host B, which one you have to go? R2. Now, if I'm R2, if you want to host B, where I have to go? Nowhere, because I'm already in the same network. So that is based on the next hub. All right, that's simple. So for you, you don't have to waste your time trying to find the whole value. So what you care about, you care what is my next hub. Simple. R1 has to find what is the next hub for him to reach out to host B. Same thing for R2. How it will reach out to the host B, right? So the other one is network specific. So for example, I'm trying to send something from S to host A. What do you think? How we want to do that? So if you're trying to use the next hop, so how we want to do that? Remember the table?
Yeah.
So if you want to do table here,
It's 2A.
okay, if they want to go to A, what they have to do?
R1.
R1. If you want to go to B,
Same R1.
what do you go C?
Same R1.
B.
R1.
Now, can we change that to use network specific? Can we do something like this? If I wanna go from network 1, because S is within network 1, and I wanna go to, I'm in network 1. I wanna go to network 2. What they have to do? They have to go to through R1. That's it. One entry.
Yeah.
Here, if you wanna use, next hop, that's mean I have to list, the path for every single host in the other end. However, for me, if you want to go from network 1 to network 2, in general, I have only one path. I have one entry. Simple. If you want to go to a network 2 from network 1, I have to go through R1. So that's that difference. So if you go here, by the way, I like this system. Finally, they give us a nice system. It was a challenge. So again, destination is R2, and just you have to find what is the next one. Simple. So now, initially, how does the table look like? If you want to use host specific, all right, A, B, C. So you have to list every single host. If you have 100 hosts, that's means I have to list 100 hosts. But since you're going from network to network, so how's the table going to look? Sorry. Yeah, maybe that's the table. So that's the table. You see how much you reduce it? Now, if you have 100 hosts here, what's the size of this table? Same. Okay. What about this size? You will have 100, right? So that's the specific network. It's much easier to find your destination. All right. Now, even if you want to go from network to network, sometimes you have exceptions. For example, if you want to send anything from host A to host B, okay, let's I decide, to always to use R3 for a reason, right? Always, because that's the shortest path. Okay. However, let's say I'm trying to send something from host A to host B, but for a reason, I want to always send it this way. It's longer, correct? You have to go, you have to pass by. But for sometimes for a reason, like this router is more secure. This router more secure, for example. So you're trying to force, so your default using the network specific. But for some specific host, like always host A, if I want to send something from host A to host B, no, I didn't want to use the default. I didn't want to go this way. I want to go this way. So that's why in the table you can force it. So if you want to go from host 2, you want to go from host 2 to 3. I'm sorry. If you want to go from A, okay, to the host 2, how you want to go that? Through R1. If you want to go to host 3, from A to host B through R3. You want to go from network 1 to network 3, so always you have to go this way. If you want to go from network 1 to N2, you go this way, correct?
Yeah.
Now, but for some reason, if I want to send a specific packet from host A, okay, I want to go to the host B, always I want to go through R3. I define that's the only path I know. So I do for a specific device, right? So it's mixed. So by default, you go this path. But there is an exception. I want to be careful. I want to use different route. So you have to identify that.
So what will be the table from N1 to N3?
From where?
N1 to
So you will have a different
network 1
table.
to network 3.
So remember this table for what? For N1, correct?
Yeah.
So now you have to, here you have in this route, in this, oh, sorry, that's the router for, that's for the host, for the host. Okay, now if you want to do a router here, for the router, you has a table. So, for example, if you want to go from R1, which is from N2 to N3, okay, what you have to do? If you want to go to R3, N3, which way you have to go? Correct? So same thing for this router here, we'll have a table here, you will have a table. Right? So each router has a table, each host will have a table. All right, so now we talk about host specific, we talk about specific. And finally we'll talk about default. So let's say you define, so if I want to go from network 1, okay, to network 2, I will use R1. If you want to go from network 1 to network 3, I will use R2. Okay. Otherwise, the default I have to use R3. So we have something called default route. Right? We'll see. So you will define specific networks, but other than that, you have to always go through this route. Right? So for example, okay, let's say host A. If you want to go to network 2, if you want to go here, so which route you want to use? All right. Same thing. If you want to go, okay, if you want, let's say you have a network here, so you will list it. Let's say you have here now N3. So if you want to go to N3, you use R, for example, R4. Right? So you will list it. Now, then what's left? If you don't have any network, you want to go to the internet because internet is huge. You cannot list all the routers. So if you're not going to the N2 or N3, you will go to the rest of the internet, and which default you will use. So that's why we call default. You always will go to the router. So when you have an IP address or packet you want to send a destination, so you will look at the destination address. If this address belongs to N1, N2, so you know the path. If it's below to N3, you know the path. Other than that, always you have to go this way. So that's the default, right? So we'll see. We'll do examples. Always examples of this. Now, as we said, you have a table. Always you have a table. So you have to, when you find, if you're trying to send a packet to a destination, you have the IP address. You have to find which path you want to go. So that's why in the classical IP addresses, they divided the routing table to 3 small tables. One for class A, one for class B, one for class C. Why? And instead of searching for the whole big table, you just divide it to A, B, C. So when you have an IP address, I will look at this IP address. If it's a class A, I don't have to visit the table B or table C. I just will go to one table. So the time searching for the destination, which way I have to go, it will be reduced. Not only that, if you have an IP address, if I give you IP address, a wrong IP address belongs to class E and D. We're not supposed to. Always we have to use only A, B, C. We cannot use D and E. So if by mistake I give you a wrong IP address, which is belong to D and E, I'm not going to say wrong, but it's belong to D and E, you should error out right away because you cannot deliver to those IP addresses. So because remember, class E is reserved. And class D, it's for broadcast. So you will not find a host has a D class address or E class address. Those nobody can. So when you build your network, always you have to design using class A, B, C. Or of course, classless. When we talk about classless, you don't have to. There's nothing called A, B, C. Just you have to use the mask to define your network. So that's we covered last chapter. So now how I will find, the route. I have an IP address. I give you an IP address. I told you, can you please find the route for me? So what you have to do first step, I will have the packet. So what you will do, I will find the destination address. Let's my destination address is 10.10.10. 20. When this class, again, I'm talking about class, okay? So can you tell what's this class? Class A, correct? It's class A, because we're talking about class A, all right? So when you do that, when you notice that's class A, all right? So what you have to do? Can you tell me which class? How do you find that class? Here, how do you find that? Correct. So what you can do, remember that the IP address is 32-bit, right? And what is how you tell what type of a class from the first 4 bits, correct? So what they can do, if I have address like this, 10, correct? 10, 10. Of course, you can have zeros. All right. Then you have a 4 zero. Then 4 zero. Then you have that's 3, and you have 0, 0. Then what's this? The 20. What's 8 plus 4? Well, 12 plus 2. 16, I have to 16. 16 plus 4. So it's going to be 0. So 1, 0, 1, 0, 0, and 0. Okay, so that's the number, right? So how we will find what is the type? Simply by shifting your number. Shift it right 28 times. So when you shift everything, what is the last 4 bit left here? 0, 0, 0, right? Because that's the first 0. So when you do the 0, 0, if your number here is between 0 to 7, that's plus 8. All right? I will show you the table. But you will find what's the class, and if it's D and E, you error out. Perfect. If it's A, B, C, what do you have to do? Table. So you will know about it because after you find what's a class, you can't tell you have to go here or here or here.
Yep.
Right? That's how's the process. Now, how we do it simply, that's actual process. Okay, we extract the destination IP. We have a packet. As remember the source and destination, we grab the destination. Okay, that's the first step. Second step, what we'll do, the destination address will shift it 28 times to the right. It will have 4 bits. This 4 bits will tell me if it's class A, B, C, D, E. How you know? If the 4 bits, the result between 0 to 7, it's class A. If it's 8 to 11, it's class B. 12 to 13, C. 14, it's D. So right away, you can tell from your hardware, right away, it's going to tell you what type of the class. After you do that, what you have to do? You have to find the network. How you find the network? Just to do by math. If it's a class A, if you have a class A, what is the network address? It's only the first 8 bits, and the remaining will be zeros. Correct? If it's a class B, what's the IP address will be? It will be the first 16 bit, then the remaining zeros. Correct? What about class B? Class C, it's going to be the first 24 bit, then the last one 0. So for example, if I have address 10.20.20.20, what is my network address? Only you mask only the first 8 bit. So remaining zeros. You will keep the first 8 bit as is, and the remaining you switch it to 0. So what's that? The network address will be 10.0.0. Okay. Now if you have 192.168.10.1, that's class C. Right? How you find the network address? By masking the first 24 bits. So you will keep the first 20 bit as is, and the remaining will make it zeros. So what is the network address here?
192.168.10.0.
Perfect. So that's the next step. Next step to find what is my network address, which network I'm going to. Okay.
Okay. Based on the class, the network address is like 8.
Yeah, so class A is 8, the first 8, I care about the first 8, class B is 16, and class C is the 24. All right, so we will find the network address. After that, since you know it's a class A, B, C, you will go search inside. If it's a class A, where you want to go and search? Just inside this table, and just that's inside table. If I find the network listed here, network address there, okay, that's me. I have to go to this
Next.
hub. It is not listed there. Where I have to go? Which route I have to go? No, I have to go through the default. So if my network is not listed here, then I have to use the default one, right? If I find it here, then I have to use this interface. It's not listed here. That means I have to go through the default. I will show you examples. Now, examples will make it clear. All right. So let's do some examples. All right. So we have a router 1. Now the diagram. So we'll we'll give you a diagram. All right. We will try to build the table. We'll see how the table is going to look like. So this router. So I'm trying to build the table for this router. This table. Okay. I need the table for this router. How are you going to do it? So simply, what we need. What's the table contain? Okay, from here. Network address. What is the next hop? And interface. Perfect. So here. Now I'm talking about R1. I will give you one example, then I will show you the answer. So we need network address. Next hop. And interface. Let's see. So I'm router 1. What is I'm trying to go from R1 to this network. What is the network address? This one. That's 0, correct? That's the network address. Okay, what is the if you wanna go from R1 to this network, what is the next hop?
No,
If you want to go from this router to this network, it's a direct connection. What does that mean? Is there a next hop here? No, there's no next hop. I'm already within the network. It's the same network.
No.
Because I'm within the network. Which interface I will use? M1, right? Work this way. So I'm using M1. Now, if you want to go this way, if you want to go to this network, what is the network address?
170.
Right. What is the next hop?
Direct.
Nothing. Because it's a direct connection. I'm already within the same network. What's the interface? Okay. Now, if I want to go from router 1 to this network, what's the network ID? 0.0.0, correct? What is the next hop? Nothing. Which interface I will use? Okay. Now, if I want to go from router 1 to this network, how are we going to do that? I will go to 16.7.0. What is the next hop? You want to go from here to here? Which
one?
I have to go through? Which interface I'm using?
M1.
0. But I'm talking about this router.
Okay.
If you want to go here, Mr. Network.
Okay.
So we do default. Okay, which way you want to go? R2 and so now, okay, now R2 or R2 we'll see it's different. I'll show you now. We'll show you. So, okay, so what we do here? But class A, what we have? That's the class A we have, right? So you're not going anywhere. Use the interface, right? If you want to do class B, where's we have class B? This two. This one class B, this one class B, correct? Okay, how's the table going to look like? If you go to class B, we'll have both and the electronics hub and second one, so correct? Now, if you want to go class C, where's the class C we have here? This one, correct? So you will go to the network. And what is the next hop?
One.
Okay. We say R2, which is through which interface we'll use this interface, because this interface is connected to that's the destination address. All right. So that's why we have this address, and which interface I'm using this interface. Now, if you want to do the default,
See.
okay, default which IP address I would use? I would use this one to access this network. And what's the interface? M0, right? So that's how you build the tables. Okay, based on that. Now the second question will be, if I give you an IP address based on this table we just filled, okay, I will tell you, I'll give you an IP address. I will ask you which route I have to pull, what is the next hub, and which interface I have to use. Correct? So what is this IP address? That's a destination. So what is the first step?
Change.
First of all, we check if it's class A, B, C, D. What this one? Class C. So I don't have to throw any error. If it's class E or class D, you should tell me, no, you cannot. It's error. You cannot do that. So it's a class C. Now, what is the network address? Can you tell me what's the network address? So first of all, how we find it's a class C?
3.
Remember what we did? We just shift 28, and that's the number left. Okay, that's 12. And remember, we say, if it's from 12 or 13, it's class C. So that's why we can tell right away it's a class C, because the last, after we shift, and the last 4 bit is 12. So that's then after that we have to find the network address. So since this is a class C, which mask I have to use? First 24. So I will it's going to be 9.2.16.7.0. That's the network address. All right. Now what's the next step? So we have to know, already created. I'm now on track. So we have it. So now which table I have to visit? Which table I have to visit? C, only C. I don't have to look at A or B. That's what I will do. I will go to class C and look. Do we have the address? Do you have the network listed there? Yes. Is that the network we just found? Yes. So okay, I found it at the table. I will know that is my next hub, and that's my interface. Let's say you went there, you could not find this one. This one was listed like 192.16.6.0. So that means it's not listed there. So what you have to tell me?
Default.
I have to use default. Clear? Another example. Okay, what this IP address? What's this class A? What? 167. So how you will do that? You shift 28. What's the last third? What is the last 4 bit? It's 10. 10 is, remember we said it from 8 to 10 is a class B. We go back
0 to 7.
from 8 to 11, it's class B. So I can tell, oh, that's class B right away. Next, what is my network address now?
Like 16. 167.24.0.
That's my network address. Now, what is the next step? I have to go to the table. Which table? I need to go table A, B, C. Which table I have to check?
B.
I have to go to B. Okay, I have to see if it's listed there. Now, remember 167.24.0.0. Now, if I go to the table B, do we have 167 dot
No.
24? 0.0. Is that listed here? No, it's not listed. So what you have to tell me, what is the next hub? Is the default. You tell me you have to use 111.30.31.18 and interface. Okay, that's the answer. Okay, so that's why we have to use the default. Clear? It's easy. Just remember that. Okay.
Even
okay.
if the network is busy or the route is busy, even default or only it's not found.
Not found. Now remember that routers, if you want to send the packet to a specific destination, you can follow different path. So router one maybe will have a bath to host B. If you go to the router C, maybe we'll have a path for host B a different way. So that's why there is always a redundancy. You cannot go to host B always the same way. There is different ways to reach out to host B. So for if for some reason you cannot reach, because sometimes let's your table telling you to go through router one. If router one goes down, that's mean you completely it. You cannot reach out to B. No, doesn't make sense.
So it is meant that it can do either connection or connectionless, depends on that situation.
That doesn't mean anything. Connection. That's how you send your packet, all right? Well, if the route available, you should have available route. Now that's why routers in general they always communicate. So for example, on router one, I'm connected to router 3, 4, 5, 6. When I see router 6 down, what I have to do? I have to update my table. Then what I have to do? I have to tell my neighbors. So my neighbors they will know, oh, now router 6 down. Let me update my table. And then the same thing. This router will send the information to the router next. That's why there is a lot of exchange there. Because network is dynamic. You will have switch up, switch down, the whole network down. So always you have that. So what we just talked about, the classful address. Now, remember we talked about something called the classful with subnet, correct? So what does mean? We have to add, if you have an IP address, 10.20.20.8 / we do at /18. Okay, what does mean? My network address is the first 18 bit. Right? So here you cannot use plus ABC because does not exist anymore because now you change your network to something. So sometimes you will have, remember when you have class A, then what we do? We divide it to a smaller networks because class A is a huge range. So you do subnetting. That's why you divide it to small networks. And for example, if you have class C, because it's small, it gives you only 256 or 256 hosts. Now, and you have a bigger network, what you do? You combine two class C to make it bigger. So you do super netting. That's why we have to add 18 to tell me, oh, that is the. So in this case, do you think we will have table for ABC? No, because now we don't have ABC anymore. Everything is combined. So now we will have a huge table, and you have to list all the networks with the subnet, and we'll see that. So what's the process? What is the process? So extract always the same thing. Extract the destination address. If the destination address match any of the host specific address in the table, then find the next hub. If not, what we do? If the destination and the mask are used to extract, so we have to extract the subnet. We'll see. Example will make it clear for you. Then after that, you will find the next hub, or you have to use the default. So simply the table. I have a destination. Based on the mask, I will find the subnet network address. So if the mask is /18, I can find what is my network address. Then when I find my network address, just I have to find it listed here somewhere. If it's not listed, I will use the default. Right? I will show you an example. All right. So that's an example. So that's my network. Okay. And that's my table. And how you create your table? Simply that's the network. Remember, since it's /18, what does mean? What /18 is? Yes. So 18. So the first 18 bit will define my network. So that's why. What is my? So yeah. So for example, I'm not gonna do 140. So 144, 145.14. Dot, what do you have? We have 0, 0, 0, 0, 8 zeros, correct? And dot 8 zeros. Right? So what is the first? The 16 bit, right? And what we will take the first two only. So that's my is. That's what happens. right? That's my network address. So what is my network address? Because zeros, it's going to be 0, 0, correct? So that's why we have this one. And which interface will we use? M0. And there's no next hop because it's there, right? So now what about this network? What is my
145.
Yeah. So I'll make it 145 is the same dot
16, 14.
14 dot. Then what is 64? It will be 0, 1, 0. Yes. It's 0, 1, 0, 0. Okay, dot 0, 0. So what is my network address from here? Which, how many, since 18, correct? I'm looking for 18. Oh, that's the first, this first two, that's 16 then I will take the first two. Right, so what is my, and the remaining will be 0. So it will be 1, 5, 4 dot, I'm sorry, 14 dot 64. That's 64 and remaining 0. It's the same network, you know. So that's how you list it there. All right. And the same thing. You will have it here. You will have it here. You will list it. And then the default. Okay, you have to go through. We did not put IP address here because we don't know what's. We did not mention what's the IP address here. But that's how it's gonna look like. So what is the difference here in the steps? You have only one table. No class table. Because we use the subnet. Mask. All right, so let me give you an example. So we have this IP address. I'm trying to send a packet to this IP address. All right. So and we know that is /18. Can you find what is the network? All right. So what is the first 18? So
145.
then here I have to. Yeah. So I will do 0, 0, 1, 0, then 0, 0, 0. Then dot 78. I'm not gonna worry about it. Okay. So when you do mask, I will do mask. But which one? So it's gonna be 145 dot 14 dot
0.
and that very zeros. So that is my. That is my. Correct. So now what I have to do? I have to go back to the table. So I'm looking for 145 plus 14. So okay, it's listed there. So which interface I have to use?
M0.
What is the next stop?
It's
Nothing,
direct.
because it's set there. Clear? Is there any questions so far? Here, before we continue. So what's the difference now between a class code without subnetting? It's easy. A, B, C. You have 3 tables. What about if you have a subnet? Now we cannot do that. It has to be one table. And you have to find it. All right. So another example. Okay, I'm trying to send something from this network to this network. And we know it's a /18, correct? So what is the /18? What's the next? So it's going to be 22. What is the 67? So 64. So it's 0 plus 64, right? That's 32. Be 64 plus 2 plus 1, right? So that means it's going to be 0, 0, 1. Correct? Then dot 91. I don't care about 91. That's because I care about the first 18. So what is the network address here? 7.22 dot 0. That is my network. Now what I have to do, I have to go back here.
Search in the table.
Do we have something called 7.22 in the table?
No.
So which interface I have to use?
Default.
M4, right? So interface 4. So if you see here, that's my network address I found. So I have to use the default one. Clear so far? If you have any question, ask me. Because this one is, you will have it in the final exam. So you need to understand that. In the exam, I will give you an IP address. Okay, I will tell you what is the next hop address and which interface that you have to use. You'll be a table. Somewhere will tell you. So, same process. So we just covered two things: classical without subnet and classical with. Now, what about if you want to use classless? The classless in the table, I need another column. What is the column?
Mask.
So I have to add the mask here because it's very important. Without the mask, I cannot tell what is the, what's the network address. Okay, how many bits for the network address? All right. So how we will find it simply, we will extract the destination, then we'll do the search. However, in the tables, we have to list, the subnets from the highest to the lowest. So for example, if you have a network it's /26, you have to do 26, then /22, then /19, then /10. But you cannot do /11.
Only in the setting.
So always, there is a reason, and we can't see that what's the reason, right? So you will start with the 26, compare the network address you found. If it's not equal, you go to the next one, you try the next one. If it's not equal, you try the third one, fourth one by one, until you find it. If you cannot find anything, then what you have to do? I'll show you an example. Okay, now we are talking about classless. So for example, so that is the network, that's a diagram. I will ask you to create a table. Create a table based on this one. And how many, we'll show you the full answer, but how many column I need?
4.
4. What's the first one? Mask.
Mask.
What's the second one? Network address. Third one? Next hop. Third one?
Interface.
All right. Simple. So, for example, what is the MAC address? And again, which one we start from?
Highest.
Highest. So, what is the highest? 26. I will start with this one. We'll see 180.70.65.3. What is the next hop? It's going to be R1. There's no next hop. So I'm predicted there. What is that? I'm sorry, network address. I'm sorry. This one, this /26. This one is the address. I'll show you now. That is next hop, and that is M2. All right. So how will the table is going to look like? So mask is 26. That is my network address. Next hop, there is nothing there. I'm using M2. So we go back. I'm talking about this network. Okay. That is my network address. And we know it's 26/26. And because it's the same network, there's no next hop. If you want to do 25, okay, what is the mask? Mask is going to be /25, correct? What is the network address? Correct. What is the next hop? See, nothing. What is the interface? You go back here. 25, network address, nothing. Clear? And you finish everything. And finally, what you will have a default. If it's default, if you go back, the default, always you have to use this interface. Right? So you look at the table back, that's the default. I'm sorry, 200. Yeah, you use this interface. Right? And which interface you'll use? Is that correct? Yes, it sounds clear. So now let's do some examples and see if we can find out. So I'm trying to send something to this IP address. What is the process? How will we find what is the next? So I'm in the router one. So what they have the first step, what they have to do?
Yeah.
That's my table, correct? So can you tell me what they have to do first step? Which one I have to try?
26.
I have to try this mask. All right? I have to try this mask. So let's find what is the network address for the mask 26. Okay? So remember 180 dot 70, right? Dot then 65.
Change it to
65 because remember how many I needed 26 bit. Then what is the last 8? It's 140. What is the 140? It's 128. 140 minus 128. We needed 12, which is 8 plus 4. Okay, so that's 128, 64, 32. 16, right? Then 8, 4, 2, 1. So that's the number, right? 1, 2, 3, 4, 5, 6, 7, 8. Yes. So what is this number? Oh, sorry. Yeah. What is this number? Which number I want to use?
Yeah.
Only this last two. Right? What is the last two? 128. So that's why my network is. You know what how we find 128, right? Because I'm looking only for the first 26 bit. That's my network address. 128 is 180, 70, 65, 128 listed in my table.
Yes.
Where?
25.
25, correct? Is listed? Is that what is my destination?
1, 8, 7. Oh, destination update. Oh, interface. And
0. What is the next hop?
nothing. That
The answer is wrong. Why? I'm doing the 26. Is the 26 is that the same network address? No,
no
that's a different.
mask.
Yes, I'm looking for the 26. If it's not equal, that means what I have to do? Go to the next. Now we will try the 25. Right? So if you go back here, now the 26 did not work. 26 is not good. Now then what we will try? The 25. How many 25? How many bits we need? Plus the 3 bits, so correct? So what is the network address? 180.70.65. 128, correct? I'll use this 3 bit. That's what they care about. It's 100. How much? 128. So that's my network. Now let's go back to the table and look for the mask with the 28. So I will go here. I'm trying 28. Okay, I'm looking here. Is that the right same network? It's the same. That's mean what is the next hop? Nothing. And I'm 0. Right? And that's the correct answer. So that's my network. When I do the 25, that's my network and exists in the table. So that's why my interface is on 0 and it's going to the same network. Right? So then after that, if you're trying to send something to this address, the same process. You will go with the 26.
Which one? 26. Earlier case 25 is the next bit. 25 bits.
Yes, first, yeah.
Then 100 will not count, right?
Here?
Yeah.
What's okay?
So for the 25, it's going to be 180, 65, and 1.
One.
Or
What's
1
the
0,
one?
yeah.
One. Two. It will take 1 bit, right?
Yeah, only 1 bit.
Okay. What's the network address?
So the same, 128.
Yeah, I made a mistake, but it's 1.
Oh.
Now here, if you want to do this one, okay. What is the if you want to try the 26 first? What is the network address? We do the math. It will be this one.
Oh.
All right. So if you go back to the table, at the 26 is that's the same address. That's the network address.
No.
Then what we'll try?
Next.
We'll try the 25.
Yeah.
What's the network for the 25? That's the network after we do the math. Is this one part of the table?
No.
Okay, that's mean the 25 did not work though. So 25 did not work. So 26 did not work, 25 did not work. Now what will we try?
24.
24. What's the network address for 24? This one.
Yeah.
Is this one, the 24 is that the same thing? 24 is the same address? That's the 24, is it has the same network address. Then that's my interface. Right? So we go back here, then we'll use okay, what is on is which match the corresponding network address. So I will use, my interface will be empty. Now another example. If this IP address. So how we will find what is the next hop? So you will try the 26,
26.
and it's not gonna match. You will not find a match. You will try the 25, you will not find a match. You will try the 24, you will not have a match. Then what you will do? Even the date table. Then you try the 22, you will not have a match. Then what's your answer? What you will tell me? You will tell me the next hop is. And the interface is right, and that's the answer to the default route. Why is default? Because first we tried the 26, we could not find the match. We tried the 25, 24, 22, we could not find match. Then we'll use the default. Clear? All right. So. Okay, now let's give us different type of example. Can we find configuration of a router if we know the table? So in the example, if I give you this table, we'll tell you, can you draw the circuit for me? Can you do it? So it's really simple, you know. So first of all, you know, we have to just draw the map. Okay, you know, that's router. Let's say, you know, router 1. We'll do that. Okay, based on the router 1, how many you have interface? It's a direct interface. You're not going to the network. You will have 1, 2, 3. That means it's direct connect. There is no. You're not going to the next hub. So what you can do? You can do M0. You can do M1. And M2, for example. Okay. Now when you go to the M0. Right. So what is the network? When you go to 0, you will go to this network. You will go to this network here. And what you can name this network? 10. 1, 2, 3, 7, 8, 9, dash 16. Right? So that's my network. But, okay, if you want to go through the M1.
180.
What is the
One.
Okay, 190, 17,
slash 16.
You want to go to this interface? It's going to be 180.
140. Sorry, 180. 180.
Slash 16. So that's the first 3. That's easy one. Now, if I want to go to a network through the M1. So remember the M1? I'm using the M1 interface. What does mean? So I have to go here through this network. So that's mean I will have another network here through router here. It's connected to another network. What is this network?
130.
It's 130. 4, 8. And through the interface 2, through here, you will have another router. You have another network, which is 140. slash 26. Right. Okay. Then what is the left? What's the last? Through the M0. That's mean through here, because I'm going through M0, I'm going to the internet. Correct? And what is the router here? You have a router, correct? Yeah, let's say R5. That's how you really draw it. You start with the network direct connected to this router. Then through the interface, you can tell which way you have to go. So if you do that, so as we said, you will have internet 0, 1, 2. So that's the network. I'm sorry, that's the first network. Through a router, you will go to the next one. Same thing. through the interface one, you will go to this network. And from this network, you will and you have the internet. Clear? It's really easy if you think about it. This one I'm not gonna read it. No, you can't read it. So, okay. So that's an example how really they do the ISPN, like the internet provider. So the internet provider, what they do, okay, you will have the regional internet provider. So they divide it to a small networks, okay, and even this sub provider or internet provider will define their IP addresses or the range even smaller. And same thing, then the next provider will make it smaller. So that's for example. Let's say that's a regional ISP. Okay, how many IP addresses has 16,000. So what they can do, they can divide that to 4, 1, 2, 3, and this unused reserved, for example, for a smaller one, and they give each one 4 gig, like 4,000, 4,000, 4,000, 4,000. And then even the local ISP, for example, let's say that's Verizon. Verizon, what they do, they divide it to even, to a smaller organization. That's how they do it. You will have, all this big internet provider, Verizon, Spectrum, all this. They will have a big range. They divide it to small ones and they assign it. So that's why they call it hierarchy ISP. So you will have a regional, then you will have local, then you will have small ISP, right? So that's how it's gonna look like. I'm not gonna ask you about the example. Oh, it's good to know. Okay, so example of forwarding based on the destination address. So that's your destination. Okay, number is based on the destination address, and you will have table. So how you will find your destination? Simply, you will go, you take the destination, start from the highest, start from the 32, try the first one, not found. Then what you have to do? Try the next one. Go one by one, by one, by one. Then, let's say, subnet mask theory. Okay, I found it. What does mean for you? So you can now tell what is the next hub
And
what is the interface. Okay, what's the issue with that?
we have to search and
You have to search one by one.
Yeah.
If you have a huge table, what's going to happen?
wait time.
It's going to take time, correct? That's why they have another way to search with using something called label. So for example, you label your destination, by a specific label. So that's why, for example, if you have an IP address and you add a label at the beginning to that. So if your label is 004, what you have to do? You just go directly here. So you don't have to search. And you will know right away what is the interface, what is the next label. So next label is before the next hub address. So that's why it's really simple. You go to label and just you will grab the interface and you grab the label address and send your packet to the next one. Right? So that's the difference. Of course, label is faster. What's the time? I have a few slides left. You want to continue? I'll finish very quick. Or you want to take a break? Yeah. So we're almost done. All right. So I said, I'm not going to cover this one. You can read it. It's not. I'm not going to ask you about it. It's simply, adding an address before the IP address, which will make it more easier. All right. Now we talk about the router, correct? Router is the responsible to find which route you have to go. So what is the router component? How many components the router has? Four components. It's easy. Can you tell me what is the first one? Yeah, but what's the component? What the actual hardware has? We'll have input port. Remember, router is connected to the one network and has another network. So you will have input port and you will have output port. What else you have? Okay, you will have something called fabric. The fabric is kind of the table, how you find what is the next hop. We'll show you example. And third one is, so what is the components? That's the router. Remember the router has input and output. So you have import, you have the output, and we have routing processor. That's how we do the search. And we have the switch fabric, and we'll show you that. All right. So the input. What's the input port? What's it responsible for? The input port performs the physical and data link layer functions of the router. Remember the router? How many layers for the router we said?
Layers?
How many layers? 3. What about the computer? How many layers?
5.
So the router has 3 layers only, not 5. Okay. Physical, data link, and network. Okay. What about the switch?
2.
What about the hub? 1. It's just repeating. Just repeating. Okay. So the input is do the physical and the data link, right? The bits are constructed from the receiver. So what you will do, that's the input port. You will receive the packet. Then what you have to do with the packet? We'll open it, correct? And from the packet, what you will do? We'll process it. You will process the data link layer. Then you will add it to the queue. Why you add it to the queue? Because your router cannot just receive one packet. You receive multiple packets. From one host, 2 hosts. You keep receiving. So he has to queue it. Then start releasing because still there's a process. Don't forget, the router has to go to the table, find what is the next hop, and that's gonna take time. If you want to wait, receive a packet and wait until you process it, then you release it. You are slowing your network. So what you have to do, you will just have a queue to process the packet, open it, find the destination address, do all this operation, make it ready, put in the queue, make it ready for the next, process or next step. So that's what why we need the queue. You have to. It's kind of a transition period. You cannot just hold the whole router for one packet until you process it. All right. So after the packet is ready, remember that the packet, we have to open it, and we have to read the destination address, and then we have to find what is the next hop. Then what we have to do?
Keep it in the queue.
We have to build it again. Perfect. You have to build it to send it out. When you send it out, it will have different physical address. Remember, as mentioned before, IP address never change. The source and destination, it always stay the same. What you change inside the packet? Only the physical address, because you will find the next physical address, next hop physical address. That's what you care about. All right. So that's why you will open it, take some information, change the packet somehow, then make it ready to send it to the next hop. So that's what's the input port will do. So again, the queues hold the packets before they are directed to switch fabric. All right. What is the output? What is the output function? It's the opposite. So you will have the queue. Okay. Then you will process the data link layer to find the next physical address. After that, and then it will have physical network layer to do something and send it out. So the opposite. The same function, but the opposite. Now let's talk about routing process. Now, what you have to do, what exactly the router job is to find the next hop. So you have a table, you have to search inside this table. And how we will do that? So what is the routing processor do? It's doing the network layer function. That's the main thing from the router, is doing network layer. The job of the router is to find the route, what is the next hop. So that's why it is performing the network layer function. All right. Destination address is used to find address of That's what you care about. I don't care about the final destination. I will use the final destination address. Why I will use it? To find what? The next.
The next hop address.
Okay. And when you find the next hop address, after that, what you have to do? Find what? MAC address for the next hop.
Physical address.
And how will we find the MAC address? Which algorithm we are using?
Yeah.
AR. Right. And that's what we do that. After we find the next hop, the output port number for which packet is sent out. So you have to find which way. Remember, we have the interface number.
Yeah.
So that's why you have to find which port you have to send out. That's from where? From where you find that? From the table. Remember, the table has the next hop address and the interface number. This activity is sometimes referred to table lookup. That's really the main thing, you know. You're trying, go over the table, search until you find where I have to go. What is the next step? And that's what we call a table lookup. Then, and even, you know, that's the thing, that's the newer router. The function of routing processor is being moved where? The input. So the new router, they don't have really something called routing processor. Okay, the input port will do the job for you. We'll do it at the same time. Why? Trying to speed up the process. You know, you don't have to delay. All right. So switching fabrics. What is this one? What's the purpose of the switching fabric? It's simply just to point. If you have interface coming through interface 1, and your table is telling you have to send that through interface 5. So what's the fabric will do? It just will direct the traffic. Will send it from interface 1 to 5. So there is a few ways to do that. We have something crossbar switch or Banyan switch or picture Banyan switch. Okay, well, so what is that crossbar switch? That's the simplest way. What is the simplest way? It's simply grid. So if you wanna send, if your input is coming here, you wanna send it to 3. What do you have to do? How do I do that? We'll open this one, open this switch, 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 open this switch. And your traffic's gonna go this way, correct? All right. So you have to open a lot of switches, correct? And that takes time and hard. That's why, if you think about it, it's not really useful. Nobody will use it. It's really costly, plus not efficient. It takes time. You have to open all the switches, right? That's why they have the second, method. It's called Banyan switch. Banyan switch simply you doing stages. So, for example, if you have 8 inputs and 8 outputs, you have to find how many stages you would have by using log 2 of n. So since you have 8, if you do log of 8 equal 3. That's why we have 1, 2, 3 stages. So that's the first item you have, and that's the exam. And the exam will tell you I'm trying to build, a Banyan for 16 inputs. It's for 4 stages. How many stages? So the answer would be 4. You have to have 4 stages. All right. Now that's the first step. Second step, what you need? How many actual switches you need in each stage? So the micro switch at each stage, how much? It's n
by 2.
N by 2. So we have 8 by 2 is 4. All right. So that's why you will have a 3 stage 1, 2, 3, 4, and you will 3, and you will have 4 switches at each stage. Correct? How many you have total here? 12. How many you have here? 16. However, here, see how many you have to open?
8.
All right. But now here's an example. If you want to send, if I have input coming to 1, I want to send this one to 6. How you will do that? So what is the 6 in binary? It's 1, 1, 0. Okay, look at me, how so simple. I'm coming here, I'm going to this switch. If it's 1, I will go this line. I will go to B4 now. Now, then what I will have? I will have 1. What's 1? It's going this way, correct? Then finally you have 0. 0 will first take the first switch. What's the output? Right? See how simple? How many switches you have to turn on?
3.
Only 3. Now, if we try another one, I have input 5, and I'm trying to send that to 2. What is 2? 0, 1, 0. So I'm starting with 5. It's going here. So what's 0? This line. I'm going this line. I'll go straight. Now then, from this micro switch, my input is 1. Then I will go to the second interface here. Then 0, which I will take the first. Okay. So same thing. If I give you in the exam, my input is 7, and I want to send that to 0. Okay. Can you tell me what's 0? 0, 0, 0, right? Now let's follow the direction. I want to start from here. 0, I will go this line, right? Another 0, I will go this line.
0.
And 0 will go here, right? So it's really simple, much easier. Okay, that's one thing. Now, however, this algorithm has an issue. You know what's the issue? If you try to forward forward, 2 inputs to the same output, what you will have? We'll have collision. How do you avoid that? Simply by adding a trap here. Okay, so what does this trap do? All the traffic comes. So let's say I'm receiving a packet. I wanna forward it to interface number 0. What I will do? I will add it to the queue, which has interface always 0. I receive another packet. I want to forward to interface 1. I will add it to the Q1. I will add it to Q2. So all this one. Then what I will do? Then I will start sending one by one. I will send one from here first. I will send one from here. Send one from here, one from here, one from here. See, one by one. So first I will send one from the 0 interface. And then the second one from the 1 interface. And in this case, you're not sending two packets going to the same interface in the same time. Then you will eliminate the conflict. All right? So that's can be another question in the exam. We will tell you what is the purpose of the trap. Okay, so we take the collision. All right, with the interface. Is there a question? That's the today class. It's fun today. I like when we have examples. It's more clear. But unfortunately, next a few classes, maybe it's kind of boring because we're talking about protocols in general. And thank you guys for the exam. I think guys, most of you did excellent in the exam. Correct? Did you try the second attempt?
I sent an email saying that I've worked on that this we'll be able to do it.
Work or exam or stuff? Huh? You had a work?
Yeah, that's work.
Work is work. You can take a thing. Exam is very important. The problem, I can't do it. I cannot make it special for every single student. It's going to be hard.